Okay, this is your exponential function introduction worksheet. Okay, we're going to go through this. This should be very simple, especially if you watch the video first, which you should have. Okay, this right here, notice that this is 2x and this is 2 to the x power. They both have 2x, but this will be an exponential function on it. This is going to be a linear function, right? So let's really quickly, all we got to do to fill this table in is multiply the x's by 2, right? So we'll get -6, -4, -2, 0, 2, 4, 6, right? Remember, our common difference is 2. That's our slope in it. This would also be 2x plus 0, and 0 is our y-intercept, right? So if we were to come down here and put 0, and our slope is 2, so if we go up 2 over 1, we would get our ordered pairs, wouldn't we? And this would graph a linear function like this, right? That would go through the origin, right? Because it has a y-intercept of 0. Over here, though, you need to remember your negative exponents. If you do 2 to the -3, remember 2 is 2 over 1. This is going to turn into 1 over 2 cubed, which is going to be 1 over 8. Okay, so when you have a negative exponent, it's going to flip your base and turn the exponent positive. You need to remember that. We did that earlier this year. So 2 to the -2 would turn into 1 over 2 squared, which should be 1 over 4, right? And then 2 to the -1 would turn into 1 over 2 to the 1, which would be 1/2. And if you put 0 in, you always get 1. And then 2 to the first would be 2, and then I'm just going to multiply by 2, aren't I? When I go down here, all I'm doing is multiplying by 2, right? This 2 isn't the slope, it's the common product. So we're going to graph this, 0, 1, and then notice over here it's going to approach the x-axis, but it never crosses it, right? And then we have 1, 2, we have 2, 4, and we have 4, 8. And so our graph would look something like this, right? Okay, and this is the graph of an exponential function, right? Which is what you learned from the video. Now then we'll go down here. For the graph f of x equals 2x, which is this, as x increases by 1, how do the y values change? They change by 2, right? They are, let's put increase by 2. By a sum of 2. The common difference equals 2, right? If you subtract your y's, you always get 2. On this one right here, how do the y values change? They change by a product of 2. And the 2 is the common product. If you divide your y's, you always get 2. Common product equals 2. Will the graph of 2 to the x power ever touch it? No. And write down the x-axis is an asymptote. It'll never cross it because your value will never be negative, okay? The x-axis is what's called an asymptote, and you should learn that on the video. Okay, the next video will be page 2. What is the domain and range of f of x equals 2 to the x? This is on the other page. I'm just going to draw the graph. Remember, the graph looked like this. The domain could be any x value, right? So your domain was all real numbers. The range could go on any y, couldn't it? So your range was also all real numbers. Most linear functions have domain and ranges of all real numbers. Now then, let's look at this one. This one had a graph that looked like this, did it? The x's could be anything, right? So our domain would be all real numbers, but our range will never ever cross the x-axis, will it? It will go close to 0, but it'll never get to it. So the range is going to be y greater than 0. Okay, f of x equals 2x is an example of a linear function, and 2 to the x power is an example of an exponential function. Okay, so a linear function would have a domain and range of all real numbers. A exponential function in the form y equals ab to the x, your domain will be all real numbers and your range is going to be all the y's greater than 0 because the x-axis will turn into an asymptote. Now then, let's go to the next one. Remember from the video, this is going to be a times b to the x, right? So this should be our y-intercept. This should be our common product, right? And we're going to graph it from -2 to 2. Okay? So if we were to plug in -2, we would have 3 times 2 to the -2, and that's going to turn into 3 times 1 over 2 squared, which will turn into 1/4, which is going to equal to 3/4 on it. 3 times 1/4 is 3/4. So this would be 3 over 4. You could use 75/100 if you want. Let's do 3 times 2 to the -1. That's going to equal to 3 times 1 over 2 to the first power. That's 1/2, right? So 3 times 1/2 is equal to 3 over 2. If you input 0, that turns into 1. 1 times 3 is 3. If you input 1, 2 to the first is 2. 2 times 3 is 6. Notice I'm multiplying by 2. 3 times 2 is 6. 6 times 2 is 12. My next number should be 12. 2 to the second power is 4, and 4 times 3 is 12, just like we said. Now then, when we graph this, we're only going from -2 to 2, so we're not going to draw arrow tips. So at -2, my range is 3/4. At -1, my range is 1.5. At 0, it's 3. At 1, it's 6. And at 2, it's 12, which will be somewhere up here. So my graph goes like this, doesn't it? So it goes from here to here. So my domain, or let's just put this, what's the y-intercept? The y-intercept is 3, which is our A. How are the y values changing? You're multiplying by 2. Is the graph increasing or decreasing? The graph is increasing from left to right. Okay, what's the range? The range is going to go from 3/4 at the bottom up to 12, right? It's going to go from 3/4 to 12. So my range is going to start at 3/4, less than or equal to y, less than or equal to, and it goes up to 12. Basically, you're putting this number here and this number here, and that determines your range if your graph doesn't have arrow tips, right? We're only going from -2 to 2. Okay, the next video will be the next page. Okay, on this one right here, remember from the video, it's a b to the x. Since b is 1/2, these numbers won't get larger, they will get smaller, won't they? This graph won't go up, it's going to go down. It's going to have decay in it. Remember from the video. Now then, let's plug in 8 times 1/2 to the -2. Remember, the negative exponent is going to flip that fraction, and when you flip the fraction, the exponent turns positive. So this turns into 8 times 2 squared. 2 squared is 4. 4 times 8 is 32. Now then, the next number should be 16 because we're going to keep taking half of this number, aren't we? So let's do 8 times 1 over 2 to the -1. This -1 exponent is going to flip that fraction. 8 times 2 over 1 to the first power. 2 to the first power is 2. 2 times 8 is 16. Notice that it went down by a factor of 2, right? Now then, if we input 0 here, this will turn into 1, and 1 times 8 is 8. So we have 32, 16, and 8. If we put a 1 right here, 1/2 to the first power is 1/2. 8 times 1/2 is 4. Notice what's happening to these numbers. They're going down by dividing by 2, aren't they? If we put 2 right here, 1/2 to the second power is 1/4. 8 times 1/4 is 2. Okay, so notice that these are decreasing by halves, aren't they? You're multiplying them by halves or dividing by 2. The graph won't go up, it'll go down. Now then, let's graph this. -2, -32 is like way up here. -116 is like about right here. 0, 8 is right here. 1, 4, and then 2, 1, or 2, 2. Okay, so my graph is going to look something like this. If I continued the graph, it would come over here, and the x-axis would be an asymptote, wouldn't it? This number and this number are going to form my range, aren't they? The y-intercept's 8, which is our A. The y values are changing by multiplying by 1/2. Remember, the 1/2 is the common product. The graph is decreasing because our b is less than 1. Spell it right. And then the range is going to go from 32 to 2, but you put the smallest one first, right? So your range, the smallest value of the range is 2, and it's going to grow to 32 in it. So these two numbers will go into your range. Okay? Now then, exponential functions in the form y equal ab to the x. The a, remember, is our y-intercept, and the b is the common product. This is just a rehash of the video, okay? A is always the y-intercept. B is always the common product. Next week, we're going to talk about this on how that each value is multiplied by. We're going to talk about how this is affecting the coronavirus and all, because the coronavirus data or those graphs are all exponential functions. If b is greater than 1, the graph is strictly increasing, and this was on the video, and it's called exponential growth. If b is less than 1, or is it between 0 and 1, is decreasing, and it's called exponential decay. And these were on the video, right? Okay, so on the next video, I will do the last page of the worksheet. Pretty simple stuff. Okay, we're going to graph 2 times 3 to the x. So let's write down 2 times 3 to the x. This will be the y-intercept, and this will be our common product, won't it? So I know my 0 is going to be 2, right? Because that's the y-intercept. And then I'm just going to multiply by 3, aren't I? So I could go down and put 6, 18, and 24, right? And then if I were to go up 1, I would divide and get 2/3. That's the shortcut to it, okay? Now then, let's go through and do the math. If I have 2 times 3 to the negative 1, that's going to turn into 2 times 1 over 3, and that equals to 2/3, which is exactly what I have. If I input 0 right here, 3 to the 0 is 1, and 1 times 2 is 2. Then 2 times 3 to the 1 is going to be 6. 2 times 3 squared is going to be, 3 squared is 9. 9 times 2 is 18. Notice my numbers work out, don't they? And then 3 to the third, this should be 54. Messed up there. Got to multiply, don't I? 3 to the third is 27, and 27 times 2 is 54. So this should have been 54. I really messed up there. Sorry about that. Okay, so right here, negative 1 is 2/3, 0 is 2, and then 1 is 6. And notice this is going to skyrocket and go off the graph, right? So it's just going to go up like this, right? To way up here. Okay, this number and this number are going to form my range, aren't they? My y-intercept should be 2. The y values are changing by a common product of 3. The graph is increasing. The range is going to go from 2/3 less than or equal to y less than or equal to 54. That's my range in it. Okay, very quickly. The last set, this is going to be on the quiz, so make sure you can do this. These numbers right here are the y-intercepts, right? A, b to the x, right? This is my y-intercept, this is my common product. Now then, if this b is smaller than 1, it's going to be decreasing, right? If b is greater than 1, it's going to be increasing. So right here, 0.25 is smaller than 1, the graph is a decay in it. Okay, right here, 4.5 is more than 1, so the graph is growth. Make sure you can do this. This will be on your quiz. Right here, the 1/4 is less than 1, so it's a decay. Right here, 3/2 is 1.5, isn't it? That's more than 1, so it's going to be growth. Okay, just go through, make sure you have this worksheet when you do your quiz. It's all complete for you, right? Take a picture of it, send it to me, and do the video, do the work on the video, take the quiz, and you will be okay for the week. This has been Mr. Toops. Always believe.